Could the worst-case scenario have already begun? In the last 50 years, the number of natural disasters worldwide has increased fivefold, and you can be sure that natural disasters are happening somewhere in the world right now. These disasters have claimed the lives of more than 2 million people. Ordinary and seemingly harmless droughts have caused the deaths of about 650,000 people. Storms have claimed more than 500,000 lives, while floods and extreme temperatures have taken about 115,000 lives. This century, the Gulf Stream, the world's largest ocean current, and the planet's core could come to a standstill. These events don't seem like mere coincidences. The Earth has already experienced 5 major mass extinctions, and today, we humans have strong reasons to believe that we are on the verge of the next one. Who knows? Maybe it has already begun. Throughout history, the largest extinctions are called mass extinctions. They don't wipe out 100% of life on the planet. Some species always survive, evolve, and then conquer the world. Therefore, there is a certain point after a mass extinction where the human population can decline without being completely wiped out. To find this number, we need to go back in time. About 74,000 years ago, a supervolcano named Toba erupted in what is now Indonesia. As a result, this accelerated the onset of the Ice Age, causing the deaths of many animals and plants. But even more frightening is that it also affected humans. During this period, the Homo sapiens population may have dropped to as low as 3,000 individuals. This process is called a population bottleneck. After a sharp population decline, the narrowest part of the bottleneck is followed by either recovery or extinction. But if you're watching this video now, humanity probably didn't disappear back then. So, if at least 3,000 people remain on the planet during the next extinction event, our species will survive. So, what exactly is threatening us? When we say mass extinction, the first thing that comes to mind is something like the impact of a giant meteor that wiped out the dinosaurs. This triggered the Cretaceous-Paleogene extinction about 66 million years ago. At that time, about 75% of the plant and animal species on Earth disappeared. The meteorite was enormous, about 10 kilometers in diameter, which is 3 kilometers larger than Mount Everest, the highest peak on Earth. Moreover, this meteor had come from space at a speed of about 20 kilometers per second. When Chicxulub hit Earth, energy equivalent to about 72 tons of TNT was released. This explosion was about 5 billion times more powerful than the bomb dropped on Hiroshima. But the destruction was not limited to the meteorite impact alone. Dust and debris thrown into the atmosphere prevented sunlight from reaching Earth. As a result, photosynthesis stopped in plants and algae, and the remaining living things began to die. So, most of the planet's animals were left without food. During the Cretaceous-Paleogene extinction, all non-avian dinosaurs and most animals weighing more than 25 kilograms disappeared. Along with them, ammonites, many other mollusks, plesiosaurs, mosasaurs, and all herbivores and carnivores disappeared. But could humans see the next day, even if Chicxulub's twin visited us? Look out the window of your office and imagine a giant flaming rock larger than Everest coming towards you from the sky. What do I do? How do I save myself? These might be the last thoughts that cross your mind before the impact. Because due to the incredibly high temperature, all living organisms within a radius of about 1,000 kilometers would be completely incinerated. For example, if another Chicxulub fell on Istanbul, about 200 million people could instantly vaporize before the impact. However, if the meteorite hit the same place as it did, 66 million years ago, in the first few seconds, about 83,700,000 people could die from the heat alone. Meanwhile, forest fires thousands of kilometers in diameter would start and eventually engulf all of North and South America. The diameter of the crater at the impact site would reach 300 kilometers, which is almost the distance from Istanbul to Eskişehir. The energy released at the moment of impact was so great that about 70,000 cubic meters of rock would simply vaporize. Just 8 minutes later, all these rocks would start to condense again and turn into scorching ash. In addition, the new Chicxulub would trigger a magnitude 10.1 earthquake. These tremors would probably be felt from Edirne to Kars. On top of that, a sudden windstorm traveling at thousands of kilometers per hour would be released at the moment of impact. This would overturn cars and demolish buildings within a 2,200 kilometers radius. Together with the devastating earthquake, it would cause the deaths of about 350 million people. But it's not over yet. If an earthquake is inevitable, so is a tsunami. In this case, the wave height would reach an incredible height of 1,500 meters. The tsunami would hit the coastlines of Europe, North Africa, and Greenland, and even reach as far as New Zealand and Australia. It would be about 30,000 times more powerful than the deadly tsunami in the Indian Ocean in 2004, which claimed the lives of about 230,000 people. If the Chicxulub scenario happened today, the number of victims of this giant wave would be at least 340 million. But the worst is yet to come. A giant amount of ash would rise into the sky after the impact and then plunge the world into darkness for 3 years. Can darkness kill you? Maybe not, but it will destroy most of the plants on the planet and kill all pets. The endless night will slowly consume all food sources and cause the death of 70% of all living things on Earth, including humans. Darkness will also lead to a sharp drop in temperature, which will cause many people to lose their lives. Due to post-disaster population decline and chaos, the progression of diseases will accelerate. People with chronic diseases will be most at risk. According to statistics from the Centers for Disease Control and Prevention, this is more than half of the United States population. As a result, the impact of this giant meteorite would reduce the human population on Earth by more than 90%, and this is a rather optimistic estimate. The good news is that humanity will indeed survive this mass extinction. The bad news is that such a doomsday scenario is entirely possible. In 2029, the Apophis asteroid will pass dangerously close to our planet. Fortunately, scientists' suspicions that we would collide with it were not confirmed. However, if such a meteor had hit Earth, the power of the impact would have been about 500 megatons, which is 10 times worse than testing a super-powerful nuclear weapon. However, asteroids are not the only source of the mass extinction threat from space. Let's go back 445 million years to a time when the Earth looked quite different. The supercontinent Gondwana, formed by the merger of Antarctica, Australia, Africa, South America, India, Arabia, and Madagascar, was a vast desert at a time when the first terrestrial plants were just emerging. Life in the ocean was rapidly evolving. The Ordovician period witnessed the Great Ordovician Biodiversification event, during which the number and variety of living species in the seas increased exponentially. And who knows, maybe if it weren't for the Ordovician-Silurian extinction, life underwater would have continued to thrive today. This was one of the largest mass extinctions in history, and 85% of marine life was wiped out from the fauna and world at that time. This means the disappearance of almost half of all animals. The loss of diversity was immense. Scientists have several hypotheses about what triggered this disaster. One of them is a supernova explosion. So, how can a star from the depths of space wipe out 56% of life forms on Earth, and can a supernova cause the extinction of humanity? In 2016, Adrian Malott, a researcher from the University of Kansas, published an article providing evidence for the direct impact of supernovae on organisms on Earth. Malott examined ocean floor samples collected from different parts of the world and found an isotope called iron-60 in each of them. The half-life of this radioactive element was 2,600,000 years, and since our planet is more than 4.5 billion years old, this iron isotope should have decayed long ago. So, where did this iron come from? Iron-60 is formed during supernova explosions. Therefore, Malott and other scientists believe that about 2.5 million years ago, a supernova exploded at a distance of 150 to 300 light-years from Earth. That's why there are still radioactive iron residues. Now imagine that such a star exploded much closer, say, only 30 light-years away from us. At such a close distance, besides a beautiful sight in the sky, The first thing we would notice would be a bright blue light. This light could be powerful enough to illuminate the night. It wouldn't disappear for a month and would disrupt melatonin production. Melatonin is a hormone responsible for the sleep process in humans. Still, insomnia wouldn't be our biggest problem. Besides the light, the Earth would be bombarded with a gamma-ray burst. These cosmic rays ionize the air as they remove electrons from atoms in the air. This creates a charge difference and would cause lightning formation. This would cause large-scale fires in forests around the planet. The most affected regions would be North America, parts of South America, Europe, North Africa, and Asia. Besides the damage, humanity would have to face the long-term consequences of the fires. Due to burning forests, a significant amount of carbon dioxide would be released into the atmosphere. At the same time, X-rays reaching Earth after the supernova explosion could destroy the ozone layer. This wouldn't just cause ordinary sunburns. DNA mutations and cancer would cause millions of people to lose their lives. Still, humanity would probably survive this event, but our population could decrease by about 90%. This event could happen relatively soon on the cosmic timescale, in about 2 billion years. Also, the Earth itself could destroy humans. About 200 million years ago, our planet experienced the largest biodiversity loss of the Mesozoic era, the Triassic-Jurassic extinction event. At that time, almost all reptiles and amphibians except pterosaurs and dinosaurs, as well as the entire class of conodonts, disappeared, a total of about 75%. The cause of this disaster was not a meteorite or a supernova explosion, but the air, or rather the change in the composition of the air due to volcanic eruptions. Due to volcanic processes, significant amounts of carbon dioxide, sulfur dioxide, and toxic mercury gas were released into the air. It was the largest and fastest carbon dioxide release in Earth's history, and the Triassic-Jurassic extinction had dire consequences. The global temperature on the planet increased by 4 degrees, and in some places up to 10 degrees. It primarily affected plants. It is estimated that 73% of plant species disappeared during the Triassic-Jurassic extinction. With this decline in plant life, herbivorous animals began to die, followed by carnivores. At the same time, another apocalypse was happening in the ocean. Due to underwater volcanism, the water became saturated with hydrogen sulfide. This changed the acidity of the ocean and, along with rising temperatures, led to the destruction of coral reefs. Oxygen depletion also affected other underwater species. But would such an extinction scenario be equally devastating for humans? According to biologists, about 800 million people worldwide depend on the oceans. If most marine life disappears, these people will simply starve to death. The temperature increase in equatorial countries will cause the deaths of at least 20 million people. But this is just the beginning. Today, someone dies of hunger every 4 seconds, which means about 9 million deaths every year. Imagine how this number would increase exponentially due to carbon dioxide emissions. Also, the mixture of gases and mercury vapor released into the atmosphere during the eruption would harm the inhabitants of the ancient Mid-Atlantic magmatic province. The remnants of this region are now scattered across various continents: central Brazil and parts of South America, some states in North and Central America, several countries in Europe, and parts of West Africa. Fortunately, a global volcanic disaster is not an immediate threat to humanity. But don't celebrate yet, because this is not the only source of carbon dioxide that can destroy us. Geophysicist Daniel Rothman believes that by 2100, the amount of carbon dioxide in the oceans will increase by at least 300 gigatons, reaching a catastrophic threshold. Rothman's research showed that this amount would be enough to trigger a new mass extinction event, which would last about 10,000 years. However, there is something that can destroy humanity much faster, and this extinction process seems to have started in 2006. At the bottom of oceans and seas, there is an ice sheet called methane hydrate, which contains large amounts of methane. This methane can remain in solid or liquid form when the right pressure and temperature balance is maintained. Chemical engineer Gregory Riskin suggested that at the end of the Permian period, the oceans could contain about 10,000 gigatons of methane, and this situation has the potential to trigger a major disaster. In particular, the activation of magmatic rocks known as Siberian traps and the melting or release of methane hydrates into the water by volcanic processes could lead to the release of more methane and initiate a chain reaction that could lead to a potential disaster. It is also stated that methane released into the atmosphere can form explosive mixtures and cause forest fires. What if one of these is disrupted by an earthquake or an abnormally warm current and triggers a chain reaction? All this methane is suddenly released, and in such a scenario, about 2.5 billion people would die instantly right next to the disaster area. Then, the explosive mixture would travel across the continent and cause massive forest fires. At the same time, gases mixed into the air would cause painful deaths from lung or brain swelling. People living at least 2,500 meters above sea level would have a chance of survival, which is just over 1% of the population. However, even in the worst-case scenario, there is still a chance for humans to survive. So, we have a chance, unless, of course, we missed something important. Survivors of a mass extinction will face incredible challenges. After the disaster, they will have to learn to find food, protect themselves, and live in a world without medicine, transportation, the internet, or communication. But most importantly, they will have to be careful against their own kind, because extinctions that may happen soon are entirely the fault of humans. What do you think about these scenarios? Don't forget to share with us. See you later.